Number 16, find the derivative of y equals 2 arc secant of 5x. All right, I know that if I have y equals arc secant of u, then y prime will equal du over the absolute value of u, square root of u squared minus a squared. Actually, this case, it's going to be u squared minus 1, I believe, so that's what we're going to use instead. Sorry about that, that's for the integral. So u squared minus 1. Okay, and then our u is going to be 5x. So if we do this, we're going to have y prime equals, I'm just going to let this 2 tag along, so it's going to be 2 times du, which would be 5, over the absolute value of u, which would be the absolute value of 5x, and then square root u squared, which would be 25x squared minus 1. Okay, now there's something we can do here. We've got y prime equals 2 times 5, and then on the bottom, the absolute value of 5 is 5, so that 5 does not need to be inside the absolute values. The x has to stay though. Okay, and then notice my 5's can cancel, so my final answer will be 2 over absolute value of x, square root 25x squared minus 1. Okay, number 17. Draw a slope field for the differential equation equals x plus 1. Alrighty, so if I do this, let me just get the picture that I gave you on your practice test. We've got -1, we've got -2, and we've got 1, and we've got 2. Okay, first of all, I noticed that if I plug -1 in here for my x values, I'm going to get 0. So all of the slope fields at x equals -1 are going to be 0. Okay, and now I'm just going to go over to 0. If I let x be 0, 0 plus 1 is 1. So all my slope fields at x equals 0 will equal 1. So I'm just going to draw lines that have a slope of 1. Okay, and then if I go over to x equals 1 and plug in 1, I will get 2. So all of my slope fields at x equals 1 will have a slope of 2, which will be a little bit steeper than the ones I drew for x equals 0. I guess I should have drawn those not quite so steep. And then when x equals 2, if I plug 2 in, I'm going to get answers of 3. So my slopes will just be slopes of 3. So I'll have to go even steeper. I'm trying to go steeper here. Alrighty, and then at x equals -2, if I plug -2 in here, -2 plus 1 is -1. So all of my slopes will be -1. And voila, we have our slope field. Problem 18, match the slope field with the equation that the slope field could represent. All right, what I'm going to do for this one is I'm just going to kind of draw the shape that I see. I do see a line that's heading like this. On this one, I definitely see a parabola. And on this one, I'm seeing something that looks like that. So I'm basically, when I match a slope field with the equation, if this is the equation, I'm just looking for the shape. So this is a line with negative slope. So I notice that y equals -2 is a line with negative slope. So this one's going to be y equals -2x. All right, and then the next one, this one is a parabola, and I know the equation of a parabola is something with an x squared in it. So this one is going to be y equals x squared minus 2x. And then this one, I notice it looks like the cosine curve, and so I'm just going to match it with the cosine curve. So you're just looking at the shape, and it's a direct match with the shape. Okay, problem 19. Evaluate the integral of 1 over x square root 9x squared minus 2. Right, by looking at this, I know that it looks similar to this formula right here. And then if it looks like that, which definitely matches the form, this is going to be 1 over a arc secant of absolute value of u over a.
What's the temperature?
350. All right, and then from here, we are going to, so I just need to identify some parts here. My u is going to be what's outside here. So actually, I need to look inside, because if this is u squared, then u would have to be 3x, and that would mean du is going to be 3 dx, and then my a, since this is, the 2 is a squared, my a will be the square root of 2. Okay, so I have to do a little bit of checking here first of all. I'm going to check my u to make sure. This is supposed to be u out front, and it's just x, but it's supposed to be 3x, so I'm going to actually put a 3 down there. But then, before I try to take care of stuff on the outside, I notice that du is 3 dx, but I only have a 1, so I'm going to put a 3 up there to make up for it. And so notice those two just cancel out, so I don't have to do anything to the outside of the problem. So since I'm all set up, everything is where it's supposed to be, I'm good to go. I'm just going to follow the formula. It's going to be 1 over a, so 1 over the square root of 2, arc secant, absolute value of u, so absolute value of u over a, which is the square root of 2, plus c. So that will be my answer for that one. Okay, problem 20. Evaluate the integral from 0 to 2 square root of 3 of 4 over the square root of 16 minus x squared. All right, I will say that this problem matches the form of du over the square root of a squared minus u squared. And if it does, it will be arc sine of u over a plus c. So that's the formula I'm going to use. The one thing that I am going to do is just bump that 4 out front since it's a constant, right? And then I just need to identify my parts. If 16 is a squared, that would make a 4. If u squared is x squared, that would just make ux, and then du would equal 1 dx, which I definitely have in my problem. So everything is set up, so I'm just going to bring down that 4 that was from the outside, and then using my formula, I have arc sine of u over a, so the arc sine of x over 4, and then instead of putting plus c, we get to evaluate it at 2 square root of 3 and at 0. So let's just plug that in. I'm going to get 4 arc sine 2 square root of 3 over 4 minus 4 arc sine, if I plug in 0, I'm going to get 0. Okay, so I'm going to have 4 arc sine u over, or 2 square root of 3 over 4 would reduce 2 square root of 3 over 2, and then minus 4 arc sine of 0. Now I just need to put my trig hat on here. The arc sine of square root of 3 over 2, if you have your handout right now, I'm thinking for where does the y value equal the square root of 3 over 2? That would be at pi over 3. So this will be 4 times the pi over 3. And then minus arc sine of 0, where does the y value equal 0? That would be at 0. So my final answer is going to be 4 pi over 3.